Hello everyone. Today I am going to discuss the most famous topic of electrostatics. From NCERT chapter 1, the most famous topic is Gauss Law. So we'll discuss Gauss Law today and we'll get to know the interesting questions which already asked in our competitive examinations like JEE, NEET. So guys, I need full attention of yours. So kindly give attention. This is the topic I am writing here, Gauss Law. This is very bold and clear I have written here, Gauss Law. So this law is very important to find electric field to any charge or charge distribution. So according to this law, you already know that the electric flux, I think you guys already gone through this topic, electric flux. It is denoted by phi and below that we have to write E to represent it. This is flux related to electric. So this is electric flux. We already know that the formula of electric flux. The formula of electric flux is phi E equal to E vector dot A vector, but between that the dot product is here, so it is a scalar quantity, electric flux. So Gauss law given some statement regarding electric flux. He has told that if there is any body which includes any charge like Q1, Q2 or Q3, it can be many more, and he has told that this surface should known as Gaussian surface. This is what? Gaussian surface. This is imaginary surface, and regarding that he has told some formula of flux. He has told that the net flux through this surface, it can be any shape, size, it will not matter. The flux is always equals to the total charge which is inside, where? Inside, divided by epsilon naught. This is the permittivity of the medium. I have taken the surrounding medium is air or vacuum, that's why I have taken here epsilon naught. This is the basic formula or law of Gauss. This is a Gauss law. So this is very important from board's point of view. This is the Gauss law. Total charge present inside the Gaussian surface, it should be counted divided by epsilon naught. This is the net flux through this Gaussian surface. This is the Gauss law. And one another formula we already have, E dot A. So this is the basic form of Gauss law. So related to that we'll discuss some questions regarding Gauss law which already asked in our previous year or this year JEE Mains paper. First we have to think what is the use of Gauss law. So I am just explaining brief because I do not take so much time to give each and everything in this lecture also. So try to understand the basic points. The first thing, the application of Gauss law, I am going to discuss first thing. If there is any conductor, this is, just imagine this is a conductor. This is the conductor cell. This is a spherical in shape. So that's why I am writing here conducting shell. Shell means it is a hollow. So this is the hollow shell. So as you know that if I will give charge on that surface, charge to the conductor, the charge will definitely come to the surface of the conductor. We already know that due to mutual repulsion, all charges come to the surface of conductor because it has path to travel inside conductors. So it came to the surface of the conductor. So if someone will ask, what is the electric field inside? Electric field inside conductor. If someone will ask, then we will definitely answer this question in very easy form because of Gauss law. Because of Gauss law, we'll make a Gaussian surface inside conductor. Yeah, this is the Gaussian surface. It is inside because we have to find electric field inside the conductor. So we already made here a Gaussian surface inside the conductor. This is the imaginary surface, so we can draw it anytime, anywhere. So this is the Gaussian surface. Gaussian surface. I am writing each and everything here so that you can imagine what is I am telling right now. So this is the Gaussian surface. As we can see that all charges are on the surface of the conductors. So there is no any charge inside the Gaussian surface. So inside charge becomes 0. Hence, we are writing here, we are applying Gauss law. From what? Gauss law. Very easy. I am just going to prove why electric field inside the conductor is 0. So this is from Gauss law. Net electric flux is Q inside by epsilon naught. This is the main formula. So we will write, as we can see that above, there is no any charge inside the Gaussian surface. Here there is no charge, no. We can see that all charges are on the surface of the conductors. So here Q inside becomes 0 by epsilon naught. Hence flux becomes 0. Flux becomes 0 inside. Where, Babu? Inside. That is enough to understand why electric field is inside 0. So another formula of flux is E dot A in vector form, or E A cos theta in a scalar form. Like this is a scalar only, no. After, if you remove dot here, the cos theta will come. So no issue. The 0 flux I have written here, E A cos theta. Here we can see that area is not 0 and electric field and the angle between area and electric field is also not 90 degree. Hence this is not 0. Hence only electric field can become 0, so that it can make electric flux 0. So electric field inside is always 0. Electric field inside is always 0 in case of conductors. Remember, if just imagine I am just taking one conductor here. Yeah, this is a conducting body. Yeah, we can see that this is spherical in shape. The electric field inside the conductor is 0. I can demonstrate it also. If I will keep mobile phone inside this conducting body, the electromagnetic wave will not enter inside the this cell because of electric field inside 0. So it cannot enter. Hence your telephone connection will get disconnected inside any cell, a spherical cell or any type of cell, any shape. If you be inside, the electric field, you will feel that it's 0. So I can demonstrate it easily if you will present inside the classroom, or definitely I will explain in another video also why it is 0. Sorry, I have already explained why it is 0. I will demonstrate it is 0. So come to the main point. Electric field inside the 0. What about outside? What about outside? Nothing. Second case, just imagine this is case 1. Just imagine this is case 1. Case 2 will discuss right now only. Just imagine this is a spherical cell. We have to just imagine total charge is Q. Not Q, just imagine we'll discuss about charge distribution also. Just imagine that all charge get distributed on the surface and the surface charge density given sigma. Sigma already we know that sigma is total charge by total area, and area of a sphere is q by 4 pi. If imagine this is radius r, then 4 pi r square. So q equal to becomes sigma into 4 pi r square. This is the total charge present on a spherical cell. So someone asked me, what is the electric field outside the sphere, which is distance r from the center, what will be the? So definitely will make one sphere also and will calculate electric flux from Gauss law, and I will definitely find electric field outside the spherical surface. I am just giving you one note. Remember one thing, this all the charges behaves like a point charge, and the electric field at that point becomes equal to kq by r square. This is the electric field due to point charge, no? This is the exactly electric field due to the sphere, charged sphere at any point outside the sphere. I am making in appropriate manner. We know that k equal to 1 by 4 pi epsilon naught, q is what? Sigma into 4 pi radius ka square. After that this r square is there, this is distance from the center. Remember, this distance is always measured from the center. 4 pi will get cancelled, and E outside of a spherical cell become sigma r square divided by r square. This is the basic formula, electric field due to a sphere outside. So this is the formula for outside, and this is the formula for inside. This is the one very famous question that can be asked in our examination. What is the electric field inside the sphere, any conductor or a spherical conductor? What is the electric field outside the spherical conductor? This is the formula for inside. We can see that it is 0, and it is always 0 besides of shape. You can take any type of shape also. So, and this is the formula for electric field outside the spherical cell. This is the first application. There are two cases, and I can also make it in graphical manner also. Just imagine this is r, this is a distance from the center, and up to here make it, this is a radius r. If a sphere, this is inside, no, till inside electric field becomes 0 only. So I am representing electric field, this axis is electric field is 0 till inside, this point is inside, and after that it is proportional to 1 by r square, because this is constant, this is proportional to 1 by r square. This also follows inverse square law also. Yeah, correct. So after that what will happen? It will decrease. So it will decrease after that. So I am representing like this. This is the electric field due to a sphere. This is inside point, this is outside point. Okay. So this is the first application of Gauss law, and one very famous application of Gauss law is second application. One famous application is second application. If imagine this is a plane sheet, having charge density sigma. As I already explained, sigma equal to q by a. Sigma means surface charge density. So this is the charge having sigma. The electric field due to plane sheet is very uniform. I am telling you, electric field due to any charged plane sheet. This is a charged plane sheet. This is the charged plane sheet. If I am taking electric field, this is like this, and all where the electric field is constant. It means due to plane charge sheet, the electric field is always uniform. And what will be the value? From Gauss law we can easily find it. We can make Gaussian surface and we can easily find it. So I am just giving you answer. The electric field due to plane charge sheet is sigma upon epsilon naught. So we can see that it is independent of r. It means here, there, anywhere, the electric field is uniform. Yes, here, there, anywhere, electric field is constant, it means uniform. So electric field is uniform due to plane charge sheet. Yeah, I am telling you truth. If someone will ask you Hey, from where we can get electric field uniform? So you can easily answer it. Due to plane infinite plane charge set, the size is infinite. In physics manner, infinite size is nothing. Like if you take electric field nearby any object, it can be imagined as the seat length is infinite. Yeah. So due to infinite plane sheet, due to infinite plane sheet, electric field is sigma upon epsilon naught, and this is uniform. So this is the one another application, very important application of Gauss law. And how we can make it Gaussian surface? We can make Gaussian surface like this also. This is the Gaussian surface, or it can be cuboidal also. So someone asked me, what if I will make one plane sheet like this and one plane sheet in front of this, both having surface charge density equal and the polarity of the both charges are different, opposite. So if I will place in like parallelly, then what will happen? This is very interesting phenomena of capacitors, parallel plate capacitors. So we have to learn it or understand it in classroom itself. So what is the formula? Then electric field inside, only electric field goes from positive to negative. Here electric field becomes 0, and here also electric field becomes 0, and here electric field becomes 2 times whatever I have given here. So not sigma upon 2 epsilon naught, I have to write sigma upon 2 epsilon naught. I was wrong, we have to write sigma upon 2 epsilon naught, not epsilon naught. Yeah, remember, I have written here sigma upon epsilon naught, that is a mistake of my pen or my thinking. I accept it. So sigma upon 2 epsilon naught should be there, and if you calculate electric field here, then electric field must be 2 times, because the electric field due to this and electric field due to this becomes add up, because here outside, here inside, and it will get added, and it will become sigma by 2 epsilon naught due to plus and sigma by 2 epsilon naught due to minus. So it will become sigma by epsilon naught due to parallel plate capacitor. So I have given 3 formula here. This is electric field due to an infinite plane charge sheet, sigma by 2 epsilon naught. This is a parallelly, if we place parallelly, then sigma by epsilon naught. This is electric field inside the conducting sphere is 0, outside is whatever, what is I have given, sigma r square by r square. So I am just taking you on the question which already asked in our this year JEE Mains examination. So kindly see this question or make it, try to solve inside the classroom, or you pause it and try to solve. All the things, answers are here, questions are here, we have to match it. So I'll match it, I'll help you. Electric field inside, charge spherical cell, I can easily point out this should be 0. So A should be 3. So for B, electric field distance r from uniformly charged infinite plane sheet. Aha, plane sheet, only one plane sheet, no? So this should be 2 sigma by 2 epsilon naught. So C, uniformly charged spherical cell is now outside. So outside should be like sigma by epsilon naught r square. Here it is dimensionally wrong. They have given wrong question. Yeah, just pointing out, because r square, I am just making it large so that you can easily understand. So this formulas left with r square also. So this option is correct, right now it is correct. For option C it will be 4, option C it will be 4, option C it will be 4. And only one answer is left and one question is left, and then obvious. So electric field between two opposite plane parallel sheets. So it is like sigma by epsilon naught 1. So D should be 1. D should be 1. So think here, all the answers are given. I think you already got to know why I was explaining Gauss law, because this is very important. One question of worth 4 marks. It is not easy to obtain such type of marks. You have to learn the first thing, you have to learn the concepts, basic concepts, then only you will definitely get to know what is the answer. So 1 3 A 3 B I have to write it, B I have to write it, electric field in probably plane sheet sigma by 2 epsilon naught, so it will be 2 3241 3241 3241. So correct option is 3241 3241. This is the JEE Mains 2025 question, as we can see here, 29th January morning shift, and we solved here in very short time. That's great. Thank you so much. Thanks for being here and getting knowledge from my side. Thanks a lot. You got a lot of knowledge. Thank you so much. Be here. Stay tuned for another video. Thank you so much.